Hey guys, I'm going to show you how to solve triangles using the law of cosines. We love the law of sines because it's easy to use and it's easy to remember, but sometimes we have to use a different rule because we don't have enough information to use the law of sines. So remember, when we use the law of sines, we have to have a given angle side pair, or we could easily figure out the angle side pair and then use that to find the other angles and sides. In the examples you do where you have to use the law of cosines, though, you don't have that information to start with. So I'm going to start by writing the formulas. So the law of cosines actually has three different forms. So the first form looks like this. We have the a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Okay, so that's a lot, and I have two more to give you, but you never use all of them at the same time. You'll pick and choose which equation you'll use based on the information that you're given. So the second version, b squared equals a squared plus c squared minus 2ac cosine angle B. And the third version, we have c squared equals a squared plus b squared minus 2ab cosine angle C. So you can tell how they're all very similar. The a, b, and c's are just in different places. So let's get started with our first example, and we'll talk about how to pick which one to use. Okay, example 1, I am given the following. Angle A is 103 degrees, side B is 65, and side C is 26. So you'll notice I don't have an A angle side pair that I could use the law of sines with, and I don't have pairs for B and C. And also, there's no way for me to find the other two angles because I only am given one. So there's no way I can start this out with the law of sines. But the information given is that I have angle A and I have sides B and C. This example is perfect for that first form of the law of cosines. So I'm going to pick the one that says that a squared equals b squared plus c squared minus 2bc times the cosine of angle A. What? Notice I have everything that goes here. What I'm going to end up solving for here is a squared, and then I can square root that, and I'll find side A. So side A is what I'm looking for. Okay, so I have a squared equals, let me sub in b and c, so 65 squared plus 26 squared minus 2 times 65 times 26 times the cosine of 103. So let me get my calculator. Okay. So a squared equals 4225, that's 65 squared, plus 676, that's 26 squared, minus, I'm going to do these right here, 2 times 65 times 26, that's 3,380 times the cosine of 103. Now I want you to be really careful here. This 3,380 is attached to cosine 103. You can't combine it with these two numbers over here. It has to stay connected to the cosine term. So I'm going to add these two first terms together, the 4225 plus 676. So I'll have a squared equals 4,901 minus 3,380 times the cosine of 103. You you can actually put all of this in your calculator as is. If not, if you do it piece by piece, just be careful. So I'm going to put it all in. So I've got 4901 minus, I'm going to make sure I use some parentheses here, 3380 times the cosine of 103. And I get this. I get that a squared equals 5,661.334564. Now remember, this is a squared. I'm looking for a. So let's square root to get a. You know I'm looking for the positive square root. So what I'm going to do in my calculator is I'm going to leave that there, and I'm just going to do square root of the answer. So for A, I get 75.24184051. I'm going to leave it with all its decimals right now because I'm going to have to use this value to find something else. Okay, so what we found was side A. It was the 75.24 and other stuff. Now, notice, I still don't know angle B and I still don't know angle C, but I now have an angle side pair. So when I find my other two angles, I'm just going to use law of sines because it's easier and because I have enough information now. When you're doing these problems, you should only have to use the law of cosines one time. After that, you'll have enough info to use the law of sines to find your other values. Okay, so I'm going to use my A side angle pair. Now here's the thing. Something great about cosine is that it's not ambiguous. Remember on the law of sines, if I solved for an angle, I sometimes had to wonder, is it acute or is this the obtuse angle that's the answer? And I had to solve for two different triangles. Cosines is not ambiguous. Anytime I solve for an angle using law of cosines, I don't have to worry about it. But don't forget, or don't let that fool you on the law of sines, because I'm going to use the law of sines to solve for my next angle. I'm going to use sine 103 over that side A. I'm not going to write it all here. I am going to use it all in my calculation. I'm going to leave it so I don't have to write it all out. And then I have to decide which angle to find. So one thing that's great about this example is the angle given was obtuse. That means I don't have to worry about B and C being obtuse. They're definitely going to be acute. But sometimes the angle given is acute. And then when I find that side and go ahead and start using the law of sines, I have to be careful because I know the law of sines is ambiguous like that. So what you do to make sure you don't have to find two different solutions is every time you go to the law of sines to find these other two angles, start by finding the smallest angle. I know angle C will be the smallest angle in the triangle because it comes from the smallest side. So if I solve for angle C, I know angle C is acute no matter what. Not just because this is given, but because the smallest angle in a triangle will always be acute. So I'm trying to get you to avoid having that ambiguity about, oh, is the angle obtuse? Is it acute? Do I need to solve two triangles? No, you shouldn't have to on these problems as long as you pick wisely. So solve for your smallest angle next, always. So I'm going to do sine C over side C, and we're solving for the sine of C. So to get the sine of C by itself, so we all know how to do law of sines at this point, we do the cross multiply. And we'll get 26 times the sine of 103. And that's going to be over that 75.241 value. And I'm going to put that in my calculator. So 26 sine 103 divided by 75.241844051 And I did something wrong. Ah. Okay, finally I got my answer here. So you guys, I'm getting a little ahead of myself. To find C, we want to do the inverse sign of this here, and I actually found that all to find C. So, like I said, I got ahead of myself a little bit, but I found that angle C has to be 19.67, let's call it 676. Okay, so now I have angle C, so we can add that to the list of things we have. So I actually have all the decimals for angle C here in my calculator because I am going to use those to find angle B. Now, from here, I used the law of cosines first because I had to. I had to find side A. Then I had enough information to use the law of sines to find the smallest angle in my triangle, which was angle C. Now that I have angle A and I have angle C, to find that third angle, just subtract from 180. So I don't even have to use law of sines again. So to find angle B, I'm looking at 180 minus 103 minus 19.676, and that continues. So let's see what I get. So what's left for angle B? 324. So there's my last piece of information for this triangle. Okay, I want to do one more example that is just like this. Bear with me while I erase once again. Okay. In this example, I am given angle C. It is 37 degrees, and side A is 26, and side B is 58. So I have different set of information. Notice I still only have one angle, two sides, no angle side pair, so I've got to use the law of cosines. You guys, because I have angle C and I have sides A and B, I'm going to use that third version of the formula that starts like this. I get C squared equals A squared plus B squared minus 2AB times the cosine of angle C. Because I have A and B and I have angle C. So what I'm going to find at the end is side C. Okay, so C squared equals 26 squared plus 58 squared minus 2 times 26 times 58 times the cosine of 37. So let's do some math in our calculators. I already know what 26 squared is because I just did it in the last problem. So I have 676 plus 3364 minus, hold on, 2 times 26 times 58 minus 3016, so 3016 times the cosine of 37. So combine these two terms. Remember, don't put this one in with these. It's a really common mistake. That's why I keep saying it. So I'm going to add the 676 plus the 3364. So I get 4040 minus 3016 cosine 37. And I'm going to put all this in my calculator as is. So I have that. Let me figure it out. 3016. So for C squared, I get 1631.315302. Don't forget to square root this to get C. So when I square root, I get C equals about 40.3895, so it would have to be 390. Again, I'm leaving the decimals in my calculator, but let's call side C 40.390 and on. Remember, just when you write your answers, round to however many places Alex wants you to. Okay, so now I have an angle side pair. Then I use the law of sines. This one, notice my given angle was acute, which means one of these angles could possibly be obtuse. Well, not A because it's smaller, but anyway, B might be obtuse. So I don't want to use the law of sines to find B because then I would have to think about two separate triangles. Instead, I'm going to use the law of sines to find angle A because I know A is acute. All right, so we're going to use sine C over C. So sine 37 over that 40.390 value equals sine of angle A over A, which was 26. So to solve for sine A, I'm going to do 26 sine 37 over the 40.390 number. Remember to do the inverse sign to get A. So the inverse sign of that is going to give me A. So let me find out what that is. All right, so I've got 26 sine 37 divided by 40.39546. I'm going to take the inverse sign of that. So for A, I get 22 point, let's call it 793. So I found angle A. At this point, remember, just subtract from 180 to find angle B. So angle B has to be 180 minus 37 minus 22.793 or so. What do we get? I get angle B is 120.207 if I round it there. I think you guys round to the 100th on Alex, but I keep going further than that. All right, so we found all of our information. One more cosines example, because you do have questions that give you a different set of information, and I want to make sure we are clear on how to do those. All right, so let's look at this problem. The issue that arises on this question is that it gives me all three sides, but it doesn't give me any of the angles. So I have A equals 32, B equals 30, and C equals 44. So I have to decide which angle to solve for, and then I'll find that angle in the version of the formula I'm going to use, and then I'll find that angle. Okay, here's the thing. Remember I said law of cosines is not ambiguous. When you solve for an angle using the law of cosines, if it's acute, your calculator will give you an acute answer. If it should have been obtuse, your calculator will give you an obtuse answer. It's not ambiguous like law of sines. So anytime that you are given all three sides and zero angles, you want to solve for the largest angle, because this is the only one that could possibly be obtuse, and if it is, the law of cosines will tell you that. That way you don't even have to question it. So, when you're using law of cosines to find an angle, you find the biggest one. When you're using law of sines to find an angle, you find the smallest one. So that's something you're just gonna have to keep in mind. So, side C is biggest, which means I wanna find angle C. I have to use the version of the formula that has angle C in it. So that's that third line. So I'm gonna use C squared equals A squared plus B squared minus 2AB cosine C. Now, I don't know C, but I do know AB and C on sides. So let's put in our information. So 44 squared equals 32 squared plus 30 squared minus 2 times 32 times 30 times the cosine of angle C. That's the only thing we don't know here. So let's do some math. So 44 squared is 1936 equals 1024 plus 900 minus 2 times 32 times 30 minus 1920 cosine C. So we're here. Put these two numbers together. Again, don't put that one with those. So 1936 equals, put these two together, you get 1924 minus 1920 cosine C. So now it's really tempting to want to do this subtraction here, but don't. What you're going to do is you're going to subtract 1924 from both sides to get this number over with the other plain number. So subtract 1924 from both sides. Notice the solving on this one's a little different because we're solving for the angle instead of the side. So you guys, when you subtract that 1924, you're going to end up with, actually I'm going to have to erase some. This tiny board. Okay, so what you're going to end up with is 12 on this side. Don't lose this negative. It's a minus 1920 cosine C. So now we're here. You guys, isolate cosine C, so basically divide both sides by negative 1920. So that's going to be a small number. So over here I get negative 0.00625 equals the cosine of C. So you guys, we know how to do this from here. If this is the cosine of C, to find C, I have to use inverse cosine. So to find C, you're going to do the inverse cosine of negative 0.00625. So I'm going to put that in my calculator and get that C is 90.3581 or so. So notice it's barely, but C is obtuse, and your calculator told you that it was obtuse, so you didn't have to worry about it. So now that you have angle C, and it's the largest angle in the triangle, so whether it comes out obtuse or not, it's the largest angle in the triangle. So when you go back and use law of sines to find angles A and B, you don't have to worry about them being obtuse, right? Because C is biggest. So you guys, from here, we found C. Your choice, we could find angle A next or angle B next. It really doesn't matter. But the way we're going to do it is we would use the side angle pair of C to then find angle A or angle B. After you find one of them, let's say you find angle A using the law of sines, remember, just subtract from 180 to find the last angle. I'm not going to complete that problem for you because we did it multiple times in the last part. You do have some word problems using the law of cosines. I did look over them, and I don't think you're going to have trouble doing the word problems the way they're written. I don't think I need to highlight any clues or tips there. If you do have trouble doing the word problems, you know, come in to the office hours meeting or send me an email and I can help there. I just don't think you're going to need it because it's just like the normal problems. So the last thing I want to do is how to find the area of a triangle. Now we have a formula for the area of a triangle that you probably remember from like geometry. The only thing is those problems were always so perfect and we had all the information. Okay guys, now that we're done with the law of cosines, let's talk about the area of a triangle. So you might remember from geometry, to find the area of any triangle, you can use the formula area equals 1/2 base times height. So a lot of times that's easy, like if it's a right triangle, you know the height, it's the straight up and down, it's the longest leg. But in the triangles we're looking at in this section, they're not right. So finding the height can be tough. So I've got a picture drawn for us. So notice I've got a triangle. I've got the sides labeled as A, B, and C. Now, looking at this triangle, it's easy to see what our base is. So A is going to be our base. Let's put that into a new formula that we're going to create. So here's 1/2 times the base, which we're calling A. The problem is the height. The height of the triangle is this dotted line I have here. So let's call that H for height for right now. Notice I have a known angle. You have to have a known angle to be able to do what we're about to do, but luckily in your examples you do have this known angle. So using that, using what I know about right triangles, we're going to find a trig ratio that finds H for us. Okay, so this line that I created as H, notice it creates a right triangle within my larger triangle. What do I know about a right triangle? Well, I know that to find H, I could create an equation that looks like this. And you tell me if you're following. Is it true that the sine of this angle theta is opposite over hypotenuse, or H over B? So can you see that? Hopefully, because I'm moving on. Remember, I want to find height. I want to find a way to describe height, not using H, but using what I have. So theta, I have B. Get height by itself by multiplying both sides by B. And what you'll find is another way to write the height of a triangle is to use this, B times the sine of theta, so the sine of the angle that you're given. Okay, so let's put that into our new area formula. So I have the base, that was A, times the height, which I'm not going to call H, I'm going to call it B sine theta. And you guys, here we are. So that was an easy formula to derive. When you find the area of a triangle in this section, you're going to use 1/2 A, B sine theta. So let's look at one example, because I think it's all you will need to be able to do this on your own. Okay, so I'm going to draw us a triangle in this example. I know that the bottom is 4, I know this side is 5, and I know this angle here is 59 degrees. So this is the kind of triangles that it's going to give you. And they might not always be oriented this way. Sometimes the angle you know is up here, and then you know these two sides. But what I want you to see that they have in common is that they give you one of the angles and they give you the sides around that angle. That's how this formula works out. So all you have to do is label one of these A, label one of them B. It doesn't matter which one because you're just multiplying them. You're going to use your two sides as A and B. Theta is the given angle, and you do area equals 1/2 AB sine theta. So what we have is 1/2 times 4 times 5 times the sine of 59. And we just stick that on our calculator. I don't know why my voice is so high right now. Okay, so 1/2 times 4 times 5 times the sine of 59. So for the area of this triangle, I get 8.57, let's call it 572, round to however many that Alex wants you to. And that's all I have to say about that. So you guys, this should get you through the rest of your objectives for this whole week. Definitely come to me with any questions that you have in the office hours or just through email.